All right, let's get right into it. We're about to unpack the incredible story of a parasitic disease, one that's as old as the Egyptian pharaohs and has a life cycle so bizarre, it honestly sounds like something straight out of science fiction. We're talking about schistosomiasis.
So picture this. It's 1798. Napoleon's army rolls into Egypt, and his soldiers start noticing something really unsettling. A huge number of local men had blood in their urine. So many, in fact, that the French troops gave the country this absolutely startling nickname. What they didn't know was that they were witnessing a telltale sign of a massive, ancient infection.
And when I say ancient, I mean ancient. This wasn't some new thing. Archaeologists have actually found the parasite's very distinct-looking eggs tucked away inside Egyptian mummies. This is hard proof that people have been fighting this invisible enemy for at least 5,000 years.
So what is this thing exactly? The official name is schistosomiasis, and it's caused by tiny parasitic flatworms. You might also hear it called bilharzia. But honestly, its most descriptive name is snail fever. And that name, well, that's a massive clue to its absolutely wild life story.
Okay, so we've established this disease has been around forever. But to really get it, we need to follow the parasite on its unbelievable journey. And it all starts with its search for a very specific partner in crime.
See, the parasite can't pull this off alone. The moment its eggs leave a human body, they're in a desperate race against time. They have to find a secret ally, an accomplice that is absolutely essential for the next stage of the plan.
Here's how it kicks off. The eggs get into a freshwater source, like a river or a lake. There, they hatch into these microscopic little swimmers. Now, here's the make-or-break moment. These tiny larvae have only 24 hours to find and infect one particular type of freshwater snail. If they don't find it in time, they just die. The snail is the whole key to the operation.
So once it's inside that snail, the parasite goes through this mind-bending transformation. It's basically building an army for the next phase of its mission, the invasion of a human. And this is where it gets really crazy. That one single larva that got into the snail, it multiplies asexually into hundreds of thousands of new fork-tailed larvae. The snail literally becomes a parasite-making factory. Then it releases this massive swarm back into the water, and they have one mission: find a human. And when they do, they can burrow right through your skin in just a few minutes.
So now it's in. The parasite is in the bloodstream, and it makes its way to the liver. There, it grows up into an adult worm, finds a mate, and the happy couple can live inside your blood vessels for years, all while laying thousands and thousands of eggs, ready to start that whole cycle over again. Okay, so the parasite has won, it's completed its life cycle. But what is the actual cost of this invasion for the person who's hosting it?
Now, this is maybe the most important part to understand. You'd think the adult worms would be the big problem, but they're not. The real damage, the actual disease, comes from the eggs. Some eggs get out of the body, sure, but many get swept away and get stuck in the body's tissues. And it's our own immune system's violent reaction to these trapped eggs that causes all the problem.
And where those eggs get stuck determines what kind of sickness you get. If they get lodged in the gut or the liver, you get intestinal schistosomiasis, think abdominal pain, and, over time, really serious liver damage. But if they get stuck in the bladder and urinary tract, well, that causes urogenital schistosomiasis. And that brings us right back to what those soldiers saw in Egypt. If an infection goes on for years and years, it is just devastating. The constant inflammation from those trapped eggs can lead to organ failure, infertility. It can even make a person more likely to contract other infections like HIV. The damage just piles up, and the consequences can absolutely be fatal. And if that wasn't bad enough, the danger doesn't stop there. The link to cancer is so clear, so definite, that the World Health Organization puts one species of this parasite in its highest possible risk category. We're talking Group 1 carcinogen, right up there with things like tobacco smoke and asbestos. So, you've got this terrible disease, but we know exactly how it works. The question then becomes, how do we fight back? How does the world try to break this ancient, vicious cycle? Well, first, you have to appreciate the sheer scale of the problem. Just in 2019, it was estimated that almost 240 million people needed treatment for this. Let that sink in. This is not some rare, obscure illness. It's a massive global health crisis. And what makes the fight even more complicated is that it's not just one parasite.
There are a few different species, and each one has its own favorite snail and lives in different parts of the world. So the one causing urinary problems is mainly in Africa and the Middle East, while others that attack the intestines are found there, but also in South America and parts of Asia. So the strategy to control it has to be a multi-pronged attack. First, you treat the infected people with a simple drug that kills the adult worms. Second, you try to control the snail population to get rid of that essential middleman. And third, and this is arguably the most important, you improve sanitation and provide clean water so you can stop the cycle from even beginning.
And all of this leads to one final, really critical question. We have a cheap, effective cure. We know the life cycle inside and out. We know exactly how to break it. So why does this so-called neglected disease still affect hundreds of millions of people? It seems the answer has less to do with the biology of the parasite and a whole lot more to do with the tough realities of poverty and global inequality.